Hi everyone, welcome back to our channel. In this video, we are going to discuss about two-sum problem. So the question is, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. So we need to return the indices of the numbers which add up to the target. You may assume that each input would have exactly one solution. So the input has only one solution and you may not use the same element twice. You can return the answer in any order. So let's understand the question better through examples. So in the example 1, nums array is 2, 7, 11, 15 and the target is 9. So we can achieve the target by adding 2 and 7. So 2 plus 7 is 9. That's why output is 0, 1, which are the indices of 2, 7. Now let's go through the example 2. In the example 2, nums array is 3 to 4 and the target is 6. So we can achieve the target by adding 2 and 4. So 2 plus 4 equals to 6. That's why output is indices of 2, 4 which is 1, 2. Now let's go through the third example. In the third example, nums array is 3, 3 and the target is 6. Clearly we can say by adding 3, 3 we get the 6. That's why output is 0, 1. Indices of this 3, 3. Let's discuss about the approaches to solve this problem. So this is our nums array 1, 3, 5, 6 and the target is 9. So in the brute force, we try every pair. First we'll pick one number and pair it with all others. So first we'll pick 1 and we'll try to add with the other elements. So first we'll add with 3 which equals to 4 and not equals to 9. And then we'll keep on moving. So now 5, 1 plus 5, 6, which is also not equal to 9. And then 6, 1 plus 6, 7 also not equals to 9. Now we'll move to the second element and we try with the other elements. As in the previous process, we already checked with the 1. So now we check with the remaining elements 3 plus 5, 8, which is not equals to 9. And then we'll move 3 plus 6. So here 9 equals to 9. We need to return these two indices which is 1, 3. This is the simple approach. So let me write pseudocode here. I equals to 0, I less than n, I plus plus. So our j starts from I plus 1 and j less than n, j plus plus. And then we just check if our nums of I plus nums of j equals to target. We just return our I comma j. So this is basic brute force. So as we know, we are using two for loops. So our time complexity is O of n square and we are not using any extra arrays. That's why space complexity is O of 1. For larger arrays, brute force is not at all suitable because O of n square is a very slow. So let's discuss about that optimized approach. So in the hash map, for each number, we ask one question, what number do I need to reach the target? Let's say for 1, if we want to reach the target, we need to check for 8 in the hash map because 1 plus 8 equals to 9. So how can we get that one? We always deduct the number from the target. So 9 minus 1, 8. So we will check for 8 in the hash map. Let's say for 3, we need to check 6 in the hash map because 9 minus 3 equals to 6. We always ask one question, what number do I need to reach the target? If it already exists, we are done, we return the indices. If not, we store the current number. Let's understand with a simple diagram. So let's say this is hash map. So as we need to return the indices, we need to store our value and index in the hash map. So first time our hash map is empty. So first we traverse through the array. So we got 1. So as we know, we will deduct from the target. So 9 minus 1, which is 8. So we will check in the hash map if 8 present or not. So as hash map is empty, we don't have 8 in the map. That's why simply we store our current number with its index. So our current number is 1 and its index is 0. So we store like this. Next number is 3. So for 3, which number we need to check? 9 minus 3 equals to 6. So still 6 not there. That's why we store 3 and its indices, which is 1. And then we move 5. So for 5, which number we need to check? 9 minus 5 equals to 4. So 4 is not there in the hash map. That's why we store 5 and its indices. And in the final, 6 came. So for 6, which number we need to check? 3. So already 3 we have. That's why simply we need to return the indices of 6 and this 3. So 6 indices is 3 and 3 index is 1. So we can return either 3 comma 1 or 1 comma 3. So this is the simple approach. So in this hash map approach, as we are traversing only once through the array, the time complexity is O of n. In the worst case, our space complexity is O of n. Though we are taking extra space also in the larger array cases, hash map is a efficient and faster. Now let's try to code for this one. So first we need to take one unordered map which is of ints, one int for value and another int for index. Now we need to traverse through the array. So every time we need to check for our required number to reach the target. So as we discussed, we need to detect from the target minus our current number. Now we need to check this required number is already existed in the map or not. How can we check? We have find function in the map. If mp.find of our required number is not equals to end of the map, then we got our indices. So now we need to return the required number index, comma, our current number index. We need to return these two indices. If we not find our required number into the map, then we need to insert our current value and its index into the hash map. In the end, we need to return empty. Let's run this one. Yeah, our solution got accepted. Let's try to submit this one. All test cases got passed. Hope you understood the problem clearly. If you have any doubt, please do let me know in the comment section. Please do like and subscribe to our channel. Thanks for watching.